Hello friends, in today's question, a solid sphere and solid cylinder of identical radii approach an inclined plane with the same linear velocity, see figure, both roll without slipping all throughout. The two climb maximum height 𝒉sph and 𝒉cyl on the incline, where 𝒉sph is a sphere and 𝒉cyl is a cylinder, then the ratio is given by. So this is a figure. These are the solid sphere and cylinder, and they are going to climb. So we have to respectively find out the height through which they are going to climb. So we know that for a pure rolling motion, for pure rolling motion, the total kinetic energy is equal to kinetic energy translational plus kinetic energy rotational. Therefore, we can write this as K will be equal to half mv square plus half I omega square. And we know that the omega is equal to V upon R, whereas the radius, therefore we can write this formula as K is equal to half mv square plus half I v square upon R square. Now we have two objects, one is sphere and another one is cylinder. Okay, so you can say now for solid sphere, kinetic energy for the sphere will be equal to half mv square plus half moment of inertia of a sphere multiplied by v square upon r square. Moment of inertia of a sphere we already know with respect to the axis, so we can say, but moment of inertia of the sphere is equal to 2 by 5 mr square. So substituting this value, we get kinetic energy for the sphere is equal to half mv square plus 1 by 2. This will be 2 by 5 mr square multiplied by v r square. So 2 and 2 cancels out, r square and r square cancels. Therefore we get kinetic energy of the sphere will be equal to 7 by 10 mv square. And similarly, we are going to write it for solid cylinder also. So therefore we can say for solid cylinder, its kinetic energy for cylinder will be equal to half mv square plus half moment of inertia for the cylinder and v square upon r square. Moment of cylinder we already know, but I cylinder will be equal to half m r square. Substituting the value, you get K cylinder is equal to half mv square plus 1 by 2 multiplied by its moment of inertia v square upon r square. r square cancels out, and we can solve it. This will be coming as kinetic energy for the cylinder will be equal to 3/4 mv square. And if they climb a height of h, okay, so you can say for h height, potential energy, which will be U, is equal to mgh. Therefore, we can say for sphere, we are going to have U sphere is equal to mgh, and height is for sphere is sph. And similarly, for cylinder, we can say U cylinder will be equal to mgh, and this will be 𝒉cyl. Now we are going to use conservation of energy. Using conservation of energy, first of all, for sphere, we are having kinetic energy of sphere is equal to potential energy of sphere, and kinetic energy of sphere we already calculated is 7/10 mv square. This gives us 7/10 mv square is equal to potential energy of sphere is mgh sphere. Mass and mass cancels out, so we get height of sphere will be equal to 7/10 v square by g. And for cylinder, similarly we can get kinetic energy of cylinder is equal to potential energy of cylinder, and kinetic energy of cylinder is 3/4 mv square will be equal to potential energy of cylinder is mg height of cylinder. Mass and mass cancels out, so here we get height of cylinder is equal to 3/4, and this will be v square by g. So we are going to find out a ratio, so simply dividing it, so we get this as height of sphere divided by height of cylinder is equal to 7/10 v square by g, 3/4 v square by g. These two terms cancels out, and we get this as 7/10 multiplied by 4/3. So this goes by 2 and 5. So this will be equal to 14/15. So the ratio h height of sphere divided by height of cylinder is equal to 14/15. And from the options available to us, we can clearly see that option number B is the correct option. From here we can say that option B is correct. So this completes the question. Thank you.